All right. In the second video of today's demonstration, we're going to be using Fusion 360, the computer-aided manufacturing module, to generate an NC file for a CNC mill. All right. So we'll head over to Fusion 360, and this is the design of the flywheel that I made in the previous video. And I'm happy with it, and I want to make an NC file for a CNC mill to execute this design here. So right now I'm in the design environment of Fusion 360. I need to switch to the manufacturer module. So I'll head over here. I guess in Fusion 360 they call them workspaces. So I'm in the design workspace. I'm going to go to the manufacturing workspace. Okay, so here it looks very similar to the design workspace, but the ribbon bar has changed. All right. So first things first, I need to set up some stock material for this. And the stock material in reality is basically a blank flywheel without this pocket in it. But all of these holes do exist in the stock material. So that's what it looks like. So I guess what I'm saying is that you don't need to put these holes into the design. That's already done in a previous step. Okay, so we'll set up the stock material by pressing setup and then new setup. I guess you can just click this button as well. So click the folder button in the setup portion of the ribbon bar, and it brings us here. So it automatically brings up this square, kind of yellowish stock here, which is not really what our stock looks like. So everything in here is okay. You can see it's pre-selected body. You know, when I click body, it already selects it in blue. And that's a good thing. So just maybe double check that before moving on. Then we're going to go to this this yellowish cube, which is the stock section of the setup, and we want to change mode. We want to change the mode. We want to change it to fixed size cylinder. So I'll click fixed size cylinder, and it's already selected the diameter correctly at 5.5 inches, but the height is way too thick. It's at 0.5 inches, and in reality, the stock is actually only 0.0625 inches. We'll change that to 0.0625. And you can see now that the stock is almost disappeared on me here, but I can still see it when I change my view. If we click the next folder here, the post process, you can change the program name, but you could also just leave it. So you can just leave it as 1001, and you may want to put in a program comment just to make sure that it's personalized. So in this case, I'm just going to call this RRC Flywheel. But you could put your name in there. You know what? I'm going to put my name in there. So Surge Flywheel. Okay. It is going to go on my Sterling engine, so I may as well call it my flywheel. Okay. And we'll leave work offset at 0. Okay. So press OK, and the stock remains showing there. So that's all set up. Now there's a couple of ways that you could, mill out these pockets. But one of the easiest ways is just to go around the outside and that would leave, some sort of inside part that would be sacrificed, and that would just get blown out with some coolant. Okay, so that's what we're going to do, and that's called 2D contours. So we'll select the 2D contour now. And once in here, there's a whole bunch of tabs here. And we'll just go through these in sequential order as we progress. So in the Tool tab, I'm going to select the tool. So if I select this button, it's actually bringing me to a library. Now I've already played around with this in Fusion 360, so some of my previous tools are showing up. But if you want to see the full tool list, they're down here under Fusion 360 Library. And we are going to go to Sample Tools Inch. Now once in here, there's a big long list of drills. You can see over here under Type, there's drills, there's radius tools, there's center drills, there's flat end mills, a ball end mill, you name it. There's just, the list goes on and on. So it's quite a comprehensive list of tools, which is nice. And I think you can actually import your own library as well. But in today's demonstration, we're just going to find a 0.125, an 1/8 inch diameter flat end mill. So this one's already being sorted by diameter, and it's actually it's already in the way that I like it. It's progressively getting to a larger diameter as I go down. Okay. So, but if it's not set up like that for you, you could just click diameter, and now it's sorting from the highest and going down. And if I select it again, it puts it in some other order. I'm not sure what order it's in. But I'll click diameter one more time, and it brings me to sorting in ascending diameters. So I'll go to 0.125 inches in diameter. And you can see there's about 10 tools here or so that all have the same diameter. And if you go to the name, we want to go to 1/8 inch length, 0.6 inch, 1/8 inch flat end mill. So we'll select that, and we'll just, I think you just double click on it and we'll select it. Okay, so I double clicked on it, and that is now showing here. The one thing that is interesting to me is that I see a number 2 here, and we actually want this to say number 1. So not exactly sure how that occurred. But I do see like a number 1 right here. And so I'm going to double click that one. And now it's changed to number 1. It's the same tool as I had before. So hopefully yours shows up as a number 1. Okay, so now I'm going to take a look at the coolant. I do want it on flood. That's what I want. And now I have my speeds and feeds. Okay, so for the spindle speed, the maximum RPM of the machine is 15,000 RPM. And I want to go that fast. So I'm going to type in 15,000 RPM. And I want the feed rate, the cutting feed rate, to be 15 inches per minute. We'll type 15 in there. And we will then go to the plunge rate of 5 inches per minute. I'm happy with that. And just to be careful, I'm going to change these lead in and lead outs to 5 as well. Although we are not going to be using these functions, if we do make a mistake, at least we're going slow. Okay, and so what will happen is that, per revolution of the cutter, we're going to remove about 0.0003 inches of material. So it's a relatively small chip that we're going to be taking out, and that will give us a really nice surface finish as we move around the pocket. Okay, so I'm happy with everything in here. I have spindle speed set to 15,000, cutting feed rate at 15 inches per minute, and the lead in, lead out, ramp, plunge, and feed rate are set to 5 inches. The feed per revolution is a calculation between my RPM and the cutting feed rate. So we'll just leave that as is. Head over to geometry here, and this is where I'm going to select the tool path. Okay, so I'm actually going to choose the tool path of where the tool is going to go. So I'm going to just go around clockwise to make sure that I select all of these pockets. I don't miss them, and I want the tool to actually move from this one to this one to this one in a clockwise fashion, so that it's not bouncing from pocket to pocket sort of randomly. I want a nice sequential tool path. That way I know what to expect when I'm watching it in the machine. Okay, so I will select this line here, and you'll see that an arrow starts moving around the part, and the line that I selected is blue. Okay, so I'm going to select the tops of all of these pockets just to ensure that the tool, when it cuts, is referencing the same height of the stock. For instance, if I was to select the bottom, it might bring the tool, lower than the rest of them when it's milling that pocket, which I would not want, because the tool might go maybe too deep into the fixture, which could damage it. So I'll just make sure to select all of the same contours on the top surface. Okay, so once this is done, I can go on to the next tab here. If you are unhappy with one of your selections, you can press Shift, hold Shift down, and deselect a line, and then select it again. If you're unhappy with the whole thing, you can head over here to this X button, and it just deletes the entire contour selection. Okay. I'm going to go over to the Heights tab. Now this is a really important tab, because we need to select the height and the depth of it cutting, and the tool retraction height from when it moves from pocket to pocket. And this is the screen we'll do it in. Okay, so I want to set the depth of the height by going to the bottom height. And right here it says select contours. But instead of selecting contours, I'm just actually going to select top of stock. Stock top. Okay, and so because all of these contours are at the same height, I can just select stock top. And I want to go through the part at negative 0.0825. And we'll look at it from a side view here. We can see that the bottom height is now 20 thousandths of an inch lower than the material. So the end mill is actually going to come down 20 thousandths of an inch lower than the material, so that we ensure that we're getting a nice clean cut on our pocket. Okay, so we'll set it to 0.0825. Then we'll leave the top height at the top of stock top at 0. And we'll leave the feed height at 0.2 inches. But I want to bring the retract height up higher. And the retract height is just the height of the tool when it moves from pocket to pocket. If it's too low, it could drag along the surface, although it is higher than the surface. But there is a little portion in the middle here of the fixture that comes above the plate, and we don't want to hit that with the tool when we move from pocket to pocket. So to be safe, I'm going to change the retract height to 1 inch. And you can see here that this line right here, this brownish line, comes up to 1 inch. So this is a distance of 1 inch. Okay, and then the retract height, or the clearance height, is just going to be 0.4 inches above the retract height. You can see that the clearance height is referencing the retract height, and that's fine with me. I'm happy with this screen. So if you want to pause the video and just review all of your numbers at this point, that is probably a good idea to do, just to make sure you got everything right. Okay. So this is the passes tab. We are going to just leave everything the same on this passes tab, and we're going to move to the linking tab. Okay, so I want to keep the linking portion the same, and then in the leads and transitions portion of the screen, I'm going to turn off the lead out, or the lead in entry, and also the lead out exit. Okay, and I want to make sure that ramp is turned off. Okay, so that completes everything. And once we do this, we just want to press OK. All right, so this is kind of cool because it now shows the tool path of what's going to happen. So let's watch and see. And we can do that by maybe selecting a view that you want to see this in, and then pressing the simulate button up here. It's this tool with this kind of spiraling square line on it. So we'll click that button and we'll press play. Now I can switch to a side view just to make sure that it's following all of the heights that I expect. So anything shown in a yellow line is a rapid motion, and that is just the motion between cutting. If we watch it again, you can see there's a red line, and that is actually the feed line. So it's actually feeding in at a certain rate at, I believe, 5 inches per minute. And then the blue line is the feed rate of the milling process when we're cutting the pocket out, when we're doing the 2D contour. Okay, and so everything appears to be as expected. We're going down about 20 thousandths of an inch, and we're retracting about 1 inch from the top of the stock every time we move to a pocket, which is what we expect. That is how we programmed this part. Now, the one thing that you may notice is that I actually selected this contour first, and then I went around. And the program did something a little bit different. It started here, down here, and then moved around. So I'm not exactly sure how to set the order at this point, and for this demonstration, it doesn't really matter in which order that it goes around and cuts the material. But it is nice to know where the part is going to start and end, so that when you're watching it in the machine, you know what's going to happen. So I would just make a mental note. Okay, it starts somewhere on the bottom left-hand side of the plate, and it's going to go around in a clockwise position, and then finally finish on the bottom right-hand side of the plate. So that would be just sort of a mental note that I take, so that when I'm looking at the machine and it actually running, I know that the program is operating as expected. Okay, so we're finally at the point of creating a NC file. And to do that, we're going to press this G1, G2 button. It's called Post Processes. And in here, we want to select a few different things. So under Post Configuration, we want to select HOS pre-NGC. And then you're going to save it in a folder that you wish. So that is in the output folder. So if you want to save it on a memory stick, you can do that. Or if you want to save it onto your desktop, you can also do that. So I'm going to save it onto my desktop. Okay, and then it's going to save it as 1001.nc. Okay, so I believe everything is as expected in here too. So we'll just press post at this point. All right, and so it's bringing me to the desktop, and I'll press save. So now that I've done that, I can see that file has opened up with Visual Studio Code. Okay, so you may be prompted at this point to download this software to be able to view your NC file, and this is how you're going to look at it. So you can see that it's saved the part number or the program number as 001001, and in the comments it's got Surge Flywheel here. And this is the code that the machine reads. So it doesn't read the Fusion 360 file, it actually reads this G code or NC file. Okay, so there's a pretty nice thing to check here. Right at the beginning, it tells me the Z minimum of the machine, and it shows negative 0.0825. So that's kind of a really nice function here, because I know that the machine or the tool won't go further in depth than that. It's also saying that it's going to use tool 1, which has a diameter of 0.0125, and that it's a flat end mill. So That's also a nice comment there, so that I know that when I go to put the tool in the machine, that I select the right tool for the job here. Okay, so finally, you'll want to put this NC file onto a memory stick. So I actually don't have a memory stick for my computer right now, but if I did, I would open up a memory stick in my file, my Windows Explorer, and I'll just do it on my desktop. We'll just pretend that my desktop is the memory stick, and you make a new folder called 001 SFR. Okay, and so the CNC machine is going to read that folder, and it will find the program, the NC file, in that folder. And so once that's done, you can take your memory stick out and then put it into the CNC machine, and it will read that file. So that completes the video series on the Flywheel CAM portion of today's demonstration.